Innovation and specialist trade exhibitions go hand in hand, and this is equally true in the world of orthopedic technology. These shows are an excellent opportunity to learn about the latest developments from Otto Bock in high-performance prosthetic technology, and also to see our revolutionary C-Leg for yourself. In their daily lives, all lower limb prosthesis wearers want to be able to move around freely and independently. Modern technology allows them to be active and live life to the full in all areas of their lives. No longer will their prosthesis be a reason for compromise in their lives. From work to family life, from holidays to adventure, C-Leg will adapt itself to the individual wearer and help them get the most from their lives in every situation. High technology delivers more quality and enjoyment of life, even allowing some C-Leg users to be more adventurous and try new experiences. Never imagined possibilities now made possible by microchip technology. Otto Bock have used our proven know-how in electronics to develop a completely new generation of prosthetic knees, based on an idea by the Canadian Kelly James, our C-Leg. C-Leg, a new dimension in the art of walking, a milestone in the development of lower limb prosthetic technology, the highlight of the World Congress of Orthopedics and Rehabilitation Technology in Nuremberg, Germany, the first fully microprocessor-controlled knee joint. Hydraulic stance phase resistance stabilizes our knee joint at heel strike. It is deactivated at the onset of load shift to the forefoot to initiate the knee swing phase. Hydraulics, servo motors, and electronic components are integrated into a carbon fiber frame. Let's take a look at the central control electronics and the sensor unit in the shin tube, including the cable connector. Expansion measuring sensors record the ankle moments during load. At heel strike, the wearer feels the reassuring stabilizing resistance effect of the hydraulics. A real advantage when walking down stairs or on slopes. These real-life situations clearly show the benefit to the wearer of the dynamic stance phase control in user safety and confidence. A carbon fiber frame securely holds and protects the internal systems. The long-lasting lithium-ion battery is located in the knee axis. The knee angle sensor records flexion and extension movements. The hydraulic unit produces the motion resistances. Servo motors adjust the hydraulic valves. Beeper and vibration alarms are provided for control and warning advice feedback to the wearer. A sensor within the tube adapter measures the ankle movements. Central command control is the nerve center of C-Leg's systems. After charging the battery, central control is online and operational. The ankle moment sensor sends data on the wearer's movements to the main processor. The knee angle sensor determines the angle position and the angle speed of the user's leg movements. Central control sends analyzed sensor data to the valve processor in order to further adjust the hydraulic valves to react to the user's movements. Data values from the slider's software are constantly providing information on the ongoing motion resistance calculations in real time. The user is warned about any changes via the vibration alarm. When the prosthesis has to carry the user's entire body weight, the stability achieved by the hydraulic components in operation are particularly impressive. A high degree of motion resistance provides stance phase stability and customer safety. Low flexion resistance initiates swing phase. When walking, high degrees of stance phase resistance alternate with low swing phase flexion resistances to provide a smooth, natural and safe walking pattern. Based on constant data flow from sensors, changes occur in real time as the user walks. This animation demonstrates the constant changes in motion resistance. High resistance during heel strike, switching to easy swing phase initiation. 50 measurements are taken per second. Sensor signals are sent to the valve processor as control impulses. Servo motors adjust flexion and extension valves and change the cross-section. Whether walking quickly or slowly, our C-Leg provides the appropriate resistance at any time and in any situation, adapting to the user's individual needs. C-Leg users live their daily lives without worry, as they no longer have to focus on controlling their prosthesis anymore. The keys to a successful C-Leg outcome are a full individual assessment and the right individual fitting advice and personal limb build. Our C-Leg can be fitted to customers weighing up to 125 kilograms, as shown by the highlighted segments in our Mobis symbol, and is for the mobility levels 3 and 4. Our C-Leg is delivered to you in an aluminium case and comes with a service record, instructions for use and other customer information. Please ensure that the service instructions are properly carried out. The frame and tube adapter from a working unit. There are 5 different lengths of tube adapters. 3 include integrated torsion adapters. The correct tube length is selected to match each customer's measurements. Tubes must never be cut or shortened, as this could damage the integrated sensor unit. Necessary adapter components are supplied in different fitting packages. They differ depending on which prosthetic foot is to be fitted. In order to assemble our C-leg, connect the wiring, push the wire loop into the tube and insert the tube into the clamp. Then check the length and rotation position on the scale. Connect the battery charger, cable and power supply and connect power. Insert the plug into the charging socket. When charging, green and yellow control diodes will light up. When the yellow diode is flashing, your battery is 50% charged. To correctly align a C-leg prosthesis, we recommend the use of a Lassar assembly alignment system. The C-walk is used here. Mount the C-leg. With the anterior placement of the knee axis at 0 to 5 mm, connect the prosthetic foot. Attach the transparent test socket with attached slider adapter and screw tight. Connect the communications cable to the PC and plug into the diagnostic socket. Start slider software and enter the password, since this software can only be used by trained and authorized personnel. When communication has been correctly established, a signal will sound. The program interface appears, showing the values stored in the knee joint. Perform a 0 setting first to calibrate the sensors. For this, the C-leg user should stand upright, fully extended and without weight applied to the prosthesis. Press the 0 setting. The toe load and knee signals will light up green. For maximum load, place the weight of the entire body onto the forefoot. The toe load achieved is displayed as a red bar. Move the square maximum load accordingly until it lights up blue. If necessary, repeat the process. The stance phase resistance is adjusted while sitting down and re-standing. The user should feel the stabilizing effect of the stance phase flexion resistance. Readjust with the slide control and try out different resistance values. In order to finally adjust the maximum load, the user should walk a couple of steps within parallel bars and check the toe load whilst the technician is watching the light bar. If the light bar's tip lights up blue, the adjustment is correct and accurate switching over to swing phase is guaranteed. Next, take off the cable and watch the gait pattern, and if necessary, make further adjustments. In order to adjust the swing phase, watch the prosthesis swing when walking freely and adjust the movement resistances. For safety reasons, the patient should stand still while making adjustments to the C-leg from the PC. First, reduce the initial swing flexion resistance. Adjust flexion operation with a dynamic factor. This should mean minimum initial resistance, but as a result, a raised dynamic factor. Adjust the extension resistance after the gait check. Activate the slider control knee angle threshold in order to finally adjust the swing phase. Test the stance phase stability and swing phase dynamics on different surfaces. The hydraulic flexion resistance of the C-leg carries the user's body weight, and this is especially noticeable on slopes or when walking downstairs. The user must practice the full flow of motion in order to gain experience and confidence. They will feel the reassuring stabilizing effect of the stance phase resistance. Check the adjusted value and try out different values. Next, check stance and swing phase performance whilst walking and increase the difficulty level. Here, the automatic speed adjustment is shown. When the user walks prescribing an inward circle, the potential can be best seen. A special second mode can also be set up for specific activities. This can be demonstrated practically by switching from first mode to second mode with the PC. The knee angle-related flexion resistance is adjusted with the slider controls to influence both start resistance and resistance progression. These range from a fully locked knee for standing to a completely free knee for activities such as bicycling. In order to switch between activity modes, the user puts load on the forefoot by tapping 3 times and then lifting the extended prosthesis. Now, for example, bicycling is easily possible using the second activity mode without flexion resistance. Switching back to the first mode is achieved in exactly the same way. In order to record the setup values, we recommend using the Lasar posture system. All adjustments are entered into the user documentation record sheet. It is important to train the user to use the battery charger every night. The user information documents contain important user information and safety instructions, which should also be fully explained and understood by the user. If necessary, at the end of the fitting, carry out any final adjustments and watch how the user reacts to the changes. An intensive training seminar is a must for C-leg fittings. Both theoretical and practical education are covered, together with practical instruction, and training is usually conducted in small groups. The delegate can perform C-leg adjustments by working with a C-leg user to practice. Especially when walking on stairs, the advantages of the C-leg's sensory control circuit become apparent. The knee's motion after stance phase flexion can be adjusted via the slide control, yielding extension resistance. This avoids abrupt knee extension. The motion sequence, which is difficult to observe, is demonstrated here using a camera mounted on a C-leg. As you can see, there is a smooth transition from stance phase flexion to knee extension. The user benefits of our C-leg in terms of walking comfort can be measured clinically in the laboratory. Metabolic energy consumption measures show clearly that less metabolic energy is used when wearing C-leg. Oxygen intake and carbon dioxide emissions are evaluated in the respiratory exhaled air. There is a special C-leg fitting package available for longer residual femoral limbs up to knee disarticulation level. The socket is connected via a lamination anchor. By using the threaded connection on the knee head, the overall construction height has been reduced by 11 millimeters. C-leg's long residual limb version opens up new fitting possibilities and greatly expands the range of possible users. This C-leg user is particularly impressive because she demonstrates the ability to master many situations whilst using a hip socket prosthesis. She has her prosthesis fully under control, even during the most difficult motion sequences. During the trade fair in Leipzig, Hans-Georg Neder, owner of the Otto Bock Company Group, was introduced to Curtis Grimsley, a New Yorker. Mr. Grimsley was amazingly able to rescue himself from a burning tower block on September the 11th, 2001, by descending 70 flights of stairs without a break whilst wearing his C-leg. Real quality of life and full social integration, and the use of high technology for improving mobility, both in normal everyday use as well as for increased capability during leisure activities. Step by step and day by day, for more independence and fulfillment in life. Quality for life.